Hello everyone, welcome back to the Quiz Learning Aptos series, and in this series we are building a full stack to-do list application on the Aptos blockchain. So far what we've done is we've written the contract. So if you go here, we've written this contract in our first video that has the create list, create task, and complete task functions defined in there. In our last video we set up our front end, and we have used the wallet adapter to get the account information of the connected wallet, and we use that to call this fetch list function inside of use effect. So this will be called every time the address field is updated. And this fetch list function, what it does is it first checks if the account is connected, and if not, it just returns an empty array. And if it is connected, we're going to get the module address from our .env file, and we're going to use the Aptos client to get the account resource. And we do that by using this function, and we pass in the account address and the resource type, which is a combination of the module address, the name of the module, and the to-do list function. To-do list struct. So this is how we get the to-do list struct that is stored inside of the account that is connected to the website now. And if that exists, then we set account has list to true, but if it doesn't exist, we set it to false. So depending on these Boolean values, we are going to display either a button that says add new list, and if this is false, then we're not going to show anything. So that's how far we've gotten so far. In today's video, we are going to finish building the whole application, and we're going to go through guide number 4, submit data, and handle task to finish off this mini series of building a full stack application. Sounds good? All right, let's get started. So submit data to chain. In the fourth chapter of this tutorial, you will be submitting data to the chain. So now we have an add new list button that appears if the connected account hasn't created a list yet. We still don't have a way for an account to create a list, so let's add that functionality. Cool. First, our wallet adapter provider has assign and submit transaction function. Let's extract it by updating the following. Okay. So we're adding this assign and submit transaction function that we get from the use wallet function. Okay. Cool. Adding that in. And an on-click event to the new list button. Gotcha. Okay, so we need to have the on-click event so that we can add a logic to the button that we created before. Okay, update the import statement from Aptos Labs Wallet Adapter React to also import the input transaction data type. All right, copy that over, and the add new list function. Okay. Oh, this I need to define myself. Okay, I'll just copy that, add new list, and I believe, yep, that's the linked function to the on-click logic on our add new list button. All right, so I'll just add that below here. Make sure it's indented properly. Nice. And what else? Since our new function also uses module address, let's get it out of the fetch list function scope to the global scope so it can be used globally. Okay, in the fetch list function, find the line module address and move it to outside of the main app function so it can be globally accessed. Okay, so if you go to fetch list, yep, let's take that and move it outside of the app function. So now this is globally accessible to everything. Nice. Let's just take a moment to see what's happening here with the add new list function. Okay, it's first checking if the account is connected. If it's not, it's gonna just return an empty array. And then we are doing this thing called transaction : input transaction data. I see. So it's a type that contains transaction information. So we pass in this data property that has the function property. So this is telling you, hey, this is the function I want you to call when you send this transaction, which is the create list function. And this function is the create list function that we have defined in our to-do list module. And the function argument is just an empty array because it doesn't take in any arguments other than the signer, and this is auto-populated. This is just the sender of the transaction. So we don't need to manually pass that in. I see. So we can also include like optional stuff where we can define like expiration seconds and timestamps. We can also add in fee pair. So if we have with fee pair to true, that's probably saying, hey, I want someone else to pay for the gas fees and not me. Very cool. We have the transaction data. Now we're going to do a try and catch where we first sign and submit the transaction to chain by using the sign and submit transaction function that we got from the wallet adapter function use wallet. Where is it? Here we go. Yeah, this one. And we're passing in the transaction. So this is actually, honest, I like to just put a space there because I was kind of confused there. Maybe it's because I'm used to the move language now, but this is just a variable, a constant value with a variable name transaction, which has the input transaction data type. Got it. So we pass that variable in over here to sign and submit this exact transaction, and we get a response. Then we have to wait for transaction. So we signed and submitted it, but we need to wait for it to be finalized and to be propagated and be added to the chain. So that's what we're doing here. So we do that by using the Aptos client, wait for transaction, and we pass in the transaction hash, which we can get from the response that we got by submitting the transaction. And then we set the account has list to true, not because we just created the list. If this fails, we keep the account has list to be false. Very simple. I like that. Cool. Let's go over the add new list function code. First, we use the account property from our wallet provider to make sure it is an account connected to our app. Yeah, we went through this ourselves, but let's just quickly skim through if it's mentioning anything that I didn't mention. We built the transaction data, function, yep, function argument, yep. Since it can take a bit for the transaction to be fully executed on chain, and we want to make sure it's executed successfully, we wait for transaction. Cool. All right, simple. Before testing our app, let's tweak our UI a bit and add a spinner component to show up while we are waiting for transaction. Add a local state to keep track whether a transaction is in progress. All right, so I'll copy that over. Let's put that under this useState right here. Cool. Update our add new list function to update the local state. Okay, so we are updating our add new list function. What's changing? I see. So we're first adding this set transaction in progress to true. So this is the spinner. And then we same thing until now, same thing, same thing, same thing. And then we add finally set transaction in progress to false. So we're just adding these two updates to the Boolean value so that we can know when the transaction is being executed. All right, so let's add that. Put it over here. And I think we just do finally. And then we just add set transaction in progress to false. Beautiful. Update our UI with the following. What are we doing? We're adding this disabled property, and we're using the transaction in progress Boolean to whether disable or enable the button. So when the transaction is being executed, this button will become unclickable because it will be disabled. Nice. Simple. Now you can head over to our app and add a new list. Since you haven't made the user interface able to handle cases where an account has created a list, you'll do so next in chapter 5. Beautiful. But let's see if everything is working as expected. So I'm going to open up my terminal and let's run npm run dev to spin up our local server. And I'm just going to bring that over here. And let's connect our wallet first. I'm going to log into my Google account and I'll come back. Great, we're logged in. now it's bringing me to the Aptos Connect page. It's going to approve, and now my Aptos Connect account is connected. All right, so we have this add new list function, and let's try calling it. I'm going to click this button. That's going to prompt me to call Aptos Connect. Beautiful. Now it says not enough APT to cover for transaction gas fees. This is probably because my account doesn't have any DevNet APT. Now I don't know if there's an easy way to fund this account with DevNet APT. Let's find out. I'm going to go to Aptos Connect app. I'm going to get the account address. And I believe there is a function in Aptos CLI that lets you fund your wallet. So let's try doing that. Aptos, I believe account. What else? Oops. Aptos account. Fund with faucet. Faucet. Oh, that just funded my default account. Okay, that's not what I wanted. I need to pass in the account that I want to fund. So that's a -- account, and let's paste in my account. Let's see if that works. Beautiful. Oh, okay, so it's quite simple. All right, so I just funded my Aptos Connect DevNet account, and let's see if it got funded. Oh, is this on mainnet? Okay, I need to change to DevNet. There we go. I got 1 APT. You know, for the hell of it, I'm just gonna fund it again one more time, and now I should have 2. Beautiful. Okay, so let's try calling create new list function. So I click that. Nice. Now we have enough APT. So I'm going to approve that transaction, and beautiful. It works. I mean, we see an empty screen, but we're going to implement this on the next chapter. But that was the first showcase of how you can use the TypeScript SDK to call your move module. And you just saw an example of me using my wallet to sign the transaction and send the transaction and execute it. So now we have a list created. Now let's try checking this. I'm going to go to my Aptos Explorer. Let's go to DevNet. And let's paste in my account that I just used. So you see, if you look at the transaction history, we just called the to-do list create list application function. So we can take a look at this transaction. Did I have an event? No, I did not. Okay, but you can see that we called the create list function. So now my account should have the to-do list resource. So if I go to my resource tab, there we go. We can see that I have the to-do list struct now stored in my account. And you can see that we have the set task event handler, the task counter, which is set to 0 because we haven't created any task yet, and the task array that it's going to be used to store all of our tasks. So you can verify that everything worked by going to the Aptos Explorer, querying your account that you used to send this transaction, and you can check out the struct that is correct, that has been created in your account. Cool. Let's continue on to chapter 5, handle tasks. The 5th and final chapter, you will add functionality to the app so the user interface is able to handle cases where an account has created a list. So I believe we're going to implement everything, add the task and complete the task and all that stuff. So far we've covered how to fetch data with chapter 3 and how to submit a transaction with chapter 4. Let's finish building our app by implementing fetch tasks and adding a task function. Fetch task. Create a local state tasks that will hold our tasks. It will be a state of a task type that has the same properties we set on our smart contract. Okay, so let's create the task type because this is TypeScript. Let's go up here, and up here we're going to create the task type, which has the address, completed, content, and task ID. And this mimics the task struct that we created in our module. So probably we're going to create the task, we're going to get the task from the blockchain, and we're probably going to store it on our front end so that we can populate it in our front end. Cool. And we're also adding this new state So let's add that. Let's put it under here. Beautiful. So this useState is gonna keep track of a local state, which is an array of tasks. We let React know that tasks type contains these properties. Beautiful. So let's continue on. Update our fetch list function to fetch the task in the account's to-do list resource. Okay, so we created the fetch list function before, right? That's this one right here. And we're updating that. So let's see what changed, and I'm just gonna copy it over. All right, so we're checking that account is connected. Then we're doing a try catch where we're getting the account resource. We're getting the to-do list struct resource from this account, the connected account. Then we're gonna set account as list to true. So far the same thing. Then we're going to create the table handle constant. We're going to get the to-do list resource as any. Okay, we're just setting it to an any type. And we're going to access the handle inside of the tasks property. I see. And we're also going to get the task counter by accessing the task counter field. Cool. Then we create an empty array called tasks. We let the counter to be 1. And we're doing a while loop where the counter is smaller or equal to the task counter. I see. Then we create the table item that contains the key type, which is a UN64 value type, to be the task struct that we defined in the module, and key to be the counter. Then we're using the Aptos client to call this getTable function, and we're getting the task table, and we're passing in the table handle and the table item. All right, let me just copy this code over, and I'm gonna kind of look at the definitions and inlay hints to see what's really happening. So delete that, paste this in again, make sure it's properly indented. There we go. All right, let's take a look. So this to-do list resource isn't any type, so I guess we need to do this. I wonder what happens if I don't do as any. Does that error? No, still works. Okay, I wonder why the guide does that, but okay, let's continue. So we're accessing the handler and the counter because the to-do list resource, if you remember, it has the tasks table, the task event handler, and the task counter. So we're getting these two things over here, the handler and the counter. And then we're going into this while loop, and we're creating the table item constant, which is an object that has the key type, value type, and key. I see. So I guess you have to define that, because over here, if you look at the table that we created, it has a key value pair of UN64 and the task struct. So that's why the value type, you have to specify that it is the task struct that we defined in the module. And the key type is UN64. And what's the actual key that we're going to use? It's going to be the counter. And we're going to start from 1. Interesting. I would expect that to be 0, but okay. Then we call this getTableItem function inside the Aptos client. So what does this do? It queries for a specific item in a table identified by the handle and the key for the item. This function allows you to retrieve structured data from a table in the Aptos blockchain. Ah, I see. So this is an example of how you can use table inside a move module and how you can access that table. So we need to pass in the table type that we are going to get, right? Right. So let's see. Yep, I see. And it's taking in the handle, which is this task event handle, I believe, right? Is it? Let's see. No, it's not. It's not. I'm sorry. So this handle we get from the tasks field, which is this, the table. So I'm not sure what table handle is. Maybe the guide will tell us later on. But okay, so we're passing in the handle and we're also passing the data, which is the table item that we created over here. And it has the data is the table item request. Okay. Alright, so what does this say? The handle argument is a pointer to where that table is stored. Ah, I see. So I guess every table has this handle field which is a pointer to where that table is stored. Cool. What about data? So data is an object that describes the table item, including key and value type. I see, so we have to let this getTableItem function know what the key value pair, the type of the key value pair is for the table. So here it has to be the move type of the table key, and for value is the move type of the table value. And this is the actual value of the table key. I see, so we have to manually specify the types of these key value pairs and what you're going to use for the key. Got it. Okay, so that is going to get the task table. So now we have the table. We got this from the blockchain, which stores the key value pairs of all of the tasks that we created. And we are going to push the task, the newly created task, to the task table. Where is that task? Oh, I see. This is just getting that on-chain task table, and we're pushing that to the task's local state that we defined over here, which is an array of tasks. Gotcha. Because this returns, what does this return? It's really nice that they give you all these examples, because this really shows how you can use these functions. Okay, let me... it returns a promise that contains the T, which is the task type. Got it. And then we're going to increment the counter. Cool. And then we continue on to get all of the tasks that we have in the table, because the counter is going to go up, which is going to be used as the key for the table. So basically, if there are 5 tasks in the table, they're all key value pairs, starting from 1, 2, 3, 4, 5, we're going to get all of those tasks, add them into the task array in our front end. Now, one thing that I want to quickly check is, why are we starting from 1? Did we define that in our move module? Let's take this over. Table. No, we start from 0. Interesting. I wonder if that's a error. I guess we'll see. Okay. So, set task in local state. I see. So we have pushed all of our tasks into the task array, and then we're going to use the set task function to set it inside of our use state so that we can use it later on. Now, if all this fails, we set account as list to false. Beautiful. Okay, I understand what's happening. So, all right, so it explains everything, but I kind of wanted to go through that myself, and I recommend you guys do this as well. Instead of just reading the guide and learning, try to figure out by reading the code yourself. That's always recommended to do. So this part is a bit confusing, so stick with us. It definitely was confusing. Tasks are stored in the table. This is how we built our contract. To fetch a table item, we need that task's table handle. We also need the task counter in that resource so we can loop over and fetch the task with the task ID that matches the task counter. Now that we have our tasks table handle and our task counter variable, yep, we got that, let's loop over the task counter. We define a counter and set it to 1 as the task counter / task ID is never less than 1. Okay. Why? Why is that? Let's go back to our module. We have the task ID. Let's create the task. Where is it? New task, counter. Ah, this is why, right here. So, remember that our to-do list task counter, when we created in our create list function, it's set to 0. So the initial value is 0. But let's say you're adding your first task by calling this create task function. The first time you do it, the code says, hey, increment the counter by 1. So for your first task that you add, the counter will be 1. Therefore, the task ID will be 1. So that's why task ID will never be less than 1. Now, everything makes sense. Gotcha. Cool. We loop while the counter is less than the task counter and fetch the table item and push it to the tasks array. Okay, what are we doing? Yep, we're looping over, yep, getting all the tasks and pushing it to the tasks array. Got that. We build a table item object to fetch. If we take a look at our table structure from our contract, it's a key value pair of UN64 and task. Yep, and whenever we create a new task, we assign the key to be the incremented task counter. Yes, I remember doing that. So the object we built is this object, where key type is the table key type. Key is the key value we're looking for, and the value type is the table value, which is a task struct. I really like this guide because this is something that's going to be super hard to learn without seeing any example. But this is really showing you how you can work with tables. And if you think about it, working with table type in a blockchain context, like on-chain state, not a lot of blockchains offer that. And it's just amazing that you can just create a table, key value pairs, and just create a table on the blockchain and keep track of everything. I love that. The task struct uses the same format from our previous resource query. The account address who holds that module equals our profile account address. Yes, that is right. The module name the resource lives in, which is to-do list, and the struct name task. The last thing we want to do is display the tasks we just fetched. In our app.tsx file, update our UI with the following code. Okay, now we're going to update the UI. Import the input using import input from components UI input. Okay, let me import that first. Go to the top. Ooh, that's not the right file. All right, input imported. And then what changed? We're adding this whole part over here. I might just copy the whole thing and replace everything. Yeah, that's simpler. So we gotta get rid of this part, paste that in. Beautiful. So before we go on, let's see what's happening. So we're checking if the account has list, the Boolean value. If this is false, we're gonna have the button add new list, which is linked to the add new list function, where you are gonna call the create list function in our move module. And it's gonna be disabled when the transaction is in progress. Now, after we do this, the account has list Boolean value is gonna be updated to true. Now, when that's the case, that's what this colon is doing. We're gonna populate this whole thing. And what we're populating is going to be, we have a list, an array of tasks, and if the task length is greater than 0, then we're going to do task.map. So we're going to go through the entire array, and for every time we loop over, we're going to get the task value, and we're going to first display the content of the task and input, which is a checkbox. So I assume we're gonna see a list of tasks with a checkbox on the right. Beautiful. Our app is coming together. So that will display the add new list button if account doesn't have a list, instead the task if the account has a list. So go ahead and refresh your browser and see the magic. All right, you guys ready for this? Let's make sure I saved everything. I do have my browser running, server running, so go here, refresh, and okay. I don't see anything. You said see the magic happen. Okay, we haven't added any tasks yet, so we don't see anything. Let's add the option to add some tasks. What magic was that? This guy, man. Okay, yay, magical. Cool. All right, let's continue. Add task. Update our UI with an add task input. Okay, this is the interesting part. So we are adding this part. It says add this. So it's going to be an input, and we have add new task. Okay, let's copy that. And where do we add this? Captain. Do we add it outside here? Maybe. Let's try that. Beautiful. Okay, now we have an input where we can pass in the tasks that we want to add and add new task. Cool. We have added a text input to write the task and a button to add the task. Create a new local state that holds the task content. Right, so that's because every time you type, this is not being stored anywhere, but we're going to have to get this value to send it over to the create task function. So how do we do that? We create this new task use state. Let's put it under all of our use states. And then find our input component, add the onChange event to it, pass it our onWrite task function, and set the input value to be the new task local state. Cool. Okay, so just going to copy that, come down here, and remember we created this input, right? But it's not doing anything at the moment, so we're going to replace that. And now the value that we type into this input section is going to be set to the new task state that we just created, because we're doing onChange. So every time we input something, we're going to call the set new task, and we're going to do e.target.value, and this is basically saying, hey, whatever that's being inputted, that's what it is. And we're going to call the set new task to set the new task. Cool. Now we have a working flow that when the user types something on the input component, a function will get fired and set our local state with that content. Beautiful. Let's also add a function that submits the typed task to chain. Yes, cool. Find our add button component and update it with the following. Okay. Yeah, we're just adding the onClick to this function. Where is it? Sorry. Here we go. On task added, and we probably have to define that. That adds an onClick event that triggers an onTaskAdded function. When someone adds a new task, we want to verify they are connected with the wallet, build a transaction payload that would be submitted to chain, submit it to chain using our wallet, wait for the transaction, and update our UI. So that's what our onTaskAdded function needs to do. So wow, that's a monster function. Let's copy that over and see what's happening. It's going to go over it, but like I said, let's go over it ourselves so that we can try to understand what the code is doing. I'm going to add it down here, and let's indent that. Cool. On task added. So, like always, we're checking if we have a connected wallet. If not, we're just going to return. Then we're going to set transaction in progress to true, because again, we are going to be sending an on-chain transaction, right? So that's going to take time, although Aptos is super fast. Then we're going to create the transaction data, which is the input transaction data type, and we're going to be calling the create task function that we defined in our to-do list module. Now you see everything is coming together. This function, we're going to call that. And the argument, because this one takes in the content argument, right? So that argument is going to be the new task string that we input into our front end. And remember, this is we're getting that from this use state that we have defined over here. So coming back, here we are. So we created that transaction data, then what are you doing? Hold the latest task.task ID from our local state. Okay, so we're gonna go to our tasks array, do .length, and if that's greater than 0, so we have some tasks, then we're gonna do the parse int, which is converting a string to an integer, and we do tasks, we do task.length -1, so that's gonna be our last task in our task array, and we're going to get the task ID of that last task. And then we're going to add 1 to that. And if the length is 0, there's no task that we previously created, we're just going to set the ID to 1. Now we're probably adding 1 here, because let's think about it, okay? So let's say there are 3 tasks. We do task.length, which is 3. But if we do task bracket 3, that's going to be out of bound because arrays start from 0. So that's why we're doing -1. So task bracket 2 is going to get the last task, the third task. Then we're going to get the task ID from that third task, which is going to be 3, right? But because we're adding a new task, the new task ID should be 4. That's why we're adding 4. Makes sense. Cool. Build a new task to function. Build a new task to push object into our local state. Okay, so we're creating a new task that we're going to push, which has the address. That's the connected account address. And we're converting that to string because the task type takes in a string type, not an address type. Come back. Where are we? Here we are. Completed to false because it's not completed yet. Content is the new task and task ID is the latest ID plus an empty string. Why? Does that just make the number to be a string by just adding it to the empty string? I see. Interesting enough, task ID is string. Why? Why is it string? Because when we get it from here, the task ID is UN64. Why did it change to string? Let's go to fetch list. We're getting the table, get the task. We're not doing any conversions there, so task ID should be a UN64 type. Maybe does, because U64 is a move number type, maybe something's happening over there because TypeScript doesn't have a U64 type, it's just number. So maybe it just automatically gets converted to string and we just gonna change that to int. I guess we'll see. Okay, let me just quickly look this up. Okay, so I just quickly looked it up because I didn't know this, but if you add a number to an empty string, this number just becomes a string. So for example, if the latest ID was 4 and we just added this to the empty string, now this becomes a string that contains 4. Interesting. I did not know that. You learn something new every day. Cool. So we created the new task that we're going to push. Then we go into try and catch, where we sign and submit the transaction. This is the transaction that we created above. We wait for a transaction, and then we create a new array based on current state. I see. So I believe we do ... tasks because we have the tasks array, but we need to kind of create a copy of that by doing ... tasks, and we store that in new tasks array, and then we push the new task to this copied array, and then we set that array to use state by doing set tasks. Now we use this spread operator to create a shallow copy of the tasks array because we don't want to make a direct modification to the original array. That's dangerous. So this is a recommended thing to do in React. You create a shallow copy, you make modifications to the shallow copy, and use that shallow copy to update the use state, the state. So that's why we're doing that. Now after we do that, we are going to clear the input text by doing set new task to an empty array. This is like cleaning up the local state. And if this errors for some reason, we're going to console log the error. And then finally, we're going to set the spinner to false. That's what this monster function is doing. Very cool. Let me save that. Now a guide's going to explain it. Let's skim through it, see if anything interesting is there. First, we use the account property. Yep, we do that. We build the transaction. Then within our try and catch, we use a wallet provider function to submit the transaction. If all goes well, we want to find the current latest task ID so we can add it to our current task state array. We'll also create a new task to push, and we display the new task in the task list on the UI without the need to refresh the page. Oh, okay, let me read this again. We will also create a new task to push to the current task state array so we can display the new task in the task list on the UI without the need to refresh the page. I see. What that's saying is because we add the new task to this tasks array, the local state, we don't need to call the fetch list function again to get the latest list. So we don't need to refresh. That's what that's saying. Try it. Type a new task in the task input, click add, approve the transaction, see it being added to the task list. Beautiful. Okay, so this is a moment of truth. I'm just gonna refresh that. Let's add a new task and see if it works. Let's add a task. What should I do? Do my laundry. I need to do my laundry today. Oh my gosh. I am so lazy. Add new task. It prompts Aptos connect. And this is the network fee. As you can see, it's super cheap. Transaction info, this is the function hash. Argument is do my laundry. You can see all these information here. Let's approve it. Boom. The list is added. Beautiful. It shows do my laundry and it has a checkbox. Nice. Now this checkbox doesn't do anything right now because we haven't set this up yet, but we've just implemented calling create task and now is populating on our front end. Beautiful. Let's finish strong and complete this application. Mark task as completed. Next, we can implement the complete task function. We have the checkbox in our UI so users can mark a task as completed. Update the checkbox component with an onCheck property that would call an onCheckbox change function once it is checked. Gotcha. All right, so let's copy that. Remember, we created this. If you come down here, we have this input. That's a checkbox, but it's not doing anything. So let's replace that. And we now have an onChange event where we call this onChainBox change that takes in the event and task ID. All right, so let's see what that's going to do. Now we're going to create the onCheckbox change function. Now we're going to create the onCheckbox change function. Wow, that's a mouthful. And let's copy this and let's go through the code again. See what's happening. All right, cool. That's indented way too much. Oops. Sorry. Just gonna do that. Cool. OnCheckBox change function. Now this function takes in an event, which is a React change event type. What is that? Does it tell me? Maybe not. Provides special properties and methods for manipulating the options, layout, and presentation of. Okay. I'm not a React expert, so honestly, I don't know what that is, but I guess we'll see. And it also takes in the task ID. So this function also checks if the account is connected. It's always smart to do this. Then we do, if event.target.checked is not true, then we return. So this is checking if the checkbox is checked. Then we're going to set the transaction in progress because we're going to call the move module function. We create the transaction data. This time we're calling complete task. And this function takes in the task ID. So let's check that. Complete task, task ID. That's why we're passing the task ID in. Then we do try catch. We sign and submit the transaction. We wait for the transaction to be finalized. Then we do set tasks. And we have the previous state. And we're going to do press state.map object. And if object.taskID is not equal to task ID, we return. If the task ID is equal to the task ID that was passed into this function, we return the shallow, a copy of the object, and completed set to true. Okay? Otherwise, return object as is. I see. So what this is doing is, remember, we have the tasks array, right? Over here, this one. And this stores all of our tasks. And each task is an object. that has this type, which contains the address, completed, Boolean type, content, and task ID. All right, keep that in mind. Now coming back here, we're going to call set tasks. So we are updating the task array that's stored in our local state, and we're creating a new state constant because we are going to take in our current list of tasks, map it, which means we're going to go through it one by one. And for each task, we're going to check if the task ID is equal to the task ID that we pass into this function. And if it is true, if it's the task that we want to update the Boolean value, that's where we update the completed field to true. Now this is all local state. It's not updating the on-chain state, right? And we return the new state. So the new state is going to be set to the task's local state. Then we catch the error, and then we finally set the transaction in progress to false. So if you look, what's interesting here is that we're doing two actions. One, we're sending a transaction to the blockchain so that we call this complete task function, which updates the table on chain. But we also need to update the list of tasks that is stored on the front end side as local state. So that's why we're doing this separately. So that's something that's interesting when you're building a blockchain application. If you want to maintain both state, you need to handle them separately. Cool. So here we basically do the same thing we did when we created a new list or a new task. We make sure there's an account connected, set the transaction in progress, build the transaction, submit it, wait for it, update the task on the UI as completed. So update the checkbox component to be checked by default if a task is already marked as completed. So this is going to, so we're not removing the completed task from the UI, we're just keeping it as checked. I see. So we have, let's take this, copy that. We need to update the checkbox component. Where is that? Is this one, right? Oh, I see. So we need to replace this entire component here, right? Okay, so let's delete that. Paste this in. Beautiful. Cannot find name list, so do I need to import that? Seems like it. It doesn't, the guide doesn't tell me, but gotta import that. Let's do quick fix. Property item does not exist in the type. Okay. That is not working. So it can be imported in the wrong thing. Is there a component in the UI? List. No. It's not there. What list are you talking about then? Did I do something wrong here? It's probably an error, right? Yep. List is not defined. Nope. That's not it. Okay. Move that. Okay. Oh wait. That's odd. Oh, that just automatically got created, that's why. Okay. Let's see. Has no corresponding closing tag. You're right. This is very confusing. I'll need to update this part. I'm so close, but this isn't working. What's odd for me here is because we're mapping already. Do I need this list? Let's try getting rid of this whole thing. I feel like this would work. No? Okay. Seems like it's working. There, it works. Well, let's see. Because we're mapping, and for each div, we're showing the content and the checkbox. Yeah, this should work. I don't know why the guide had the list.item, but let's see if it works, and let's try it. Let's add another task just to be sure. Let's say buy groceries. Add new task. Approve. Good, that works. I'm just gonna that. All right, now we have 2 tasks. Let's try completing do my laundry. Let's say I did that. Assign the transaction. There, it works. So now it's disabled, like we said in the code. So we have the input checkbox. If the check is true, then it's disabled. Nice, I like that. Okay, and let's also complete by grocery. And there, it works. Okay, so that code example on the guide, a bit misleading. This really is not needed over here. So I'll make a note of that and make sure I change that so it doesn't confuse you guys. Cool. So try to check out the task, checkbox approve the transaction, see the task marked as completed. And beautiful, I have completed building the end-to-end to-do list application on the Aptos blockchain. Congratulations you guys for getting to this end of this guide. Wow, that was a journey. But before we end this video, let's go to the Explorer again and check our resource. So just gonna refresh that. And yeah, now we see the task counter to be 2. Not seeing any tasks. Oh, is that because do we remove it? No, we don't remove it. Huh, I thought I would see it in the to-do list struct. Right? Let's see. Tasks. Do I need to... I wonder if I look this up, will it show? No, that's just an account. No. I guess it doesn't show here. Okay. But you can see that we have created 2 tasks, completed 2 tasks, and did we have an event? Let's see. No, not for this one. So for creating task, I believe we did create an event, right? Yeah, you see the event is being created for creating a task. Beautiful. But yeah, now we have a working application. Obviously, it looks horrible. So maybe this is a chance for you guys to take this boilerplate UI, vibe code something, make it pretty. And if you do, share it on socials. Let us know what you build and get your Aptos developer journey started. But that's it for this end-to-end mini series. We built a full stack application, starting from writing a smart contract, setting up our front end, hooking it up with our published module on chain, and updating our UI based on the on-chain activity that we do. So hopefully this has given you kind of a high-level overview, an idea of how all of these components work and are intertwined with each other. And now you know enough to go ahead and build your own application on the Aptos blockchain. That being said, thank you so much for watching till the end of this video. I know it was a long one, but hopefully you found it helpful. Let us know in the comments if you have any feedback for the guide or the video content that you just watched. But yeah, thank you so much for going through this with me, and I'll see you in the next one. Bye.